So in this video I'm going to talk about functional groups, and I briefly mentioned what a functional group is in the class today. So functional group is an arrangement of atoms based on specific elements, which is going to be part of an organic structure. So for example, the simplest functional group we saw in the class today is an alkane. So what is an alkane? An alkane is a hydrocarbon with only carbon-carbon and carbon-hydrogen bonds, and it contains only single bonds, which means they are saturated. So any straight chain or even cyclic structures, as long as you have only carbon-carbon single bonds and carbon-hydrogen bonds, that is an alkane. So this is an example of an alkane. This is an alkane. This is a cycloalkane, which is same as an alkane in terms of functional group, and so on and so forth. So alkanes contains only carbon-carbon bonds and carbon-hydrogen bonds, and it's only single bonds, and they are all saturated. That's an alkane. An alkene, on the other hand, is a molecule which is a hydrocarbon, and along with possible carbon-carbon single bonds, it is also going to have, of course, carbon-hydrogens also. It should have at least one carbon-carbon double bond. It should have at least one carbon-carbon double bond. So that is an alkene. So it has double bond between two carbons. So an example of an alkene would be something like that. That is an example of an alkene as well. And you can have multiple double bonds as well. So you can have a double bond that looks like that. This is also an alkene. This is a monoalkene. This is a dialkene. So as long as you have at least one carbon-carbon double bond, you call this an alkene. The next structure is going to be, a functional group is going to be alkyne, Alkyne. So alkyne is also a hydrocarbon. It might have carbon-carbon single bonds. It obviously can also have carbon-hydrogen bonds, but as long as they have at least one carbon-carbon triple bond, you call that an alkyne. So an example would be that would be an alkyne. That would be an alkyne. And of course, it goes without saying that this alkyne also has an alkane functional group in it as well. But alkanes are considered to be the most basic structure which is going to be present in pretty much all organic molecules. So it is not necessary to explicitly say that you have an alkane along with the alkyne here, and you have an alkane functional group along with the alkene here. So if you have a double bond, it's simply enough to call this an alkene. You don't have to say this is an alkane and an alkene. So anyway, this is an alkyne, so this is an alkyne as well, because it has at least one carbon-carbon triple bond. So if we have a structure, for example, that is going to have both double bonds and triple bonds, then in this case you will have to say that you have alkyne functional group as well as an alkene functional group. The only thing that you don't have to explicitly say that you have an alkane functional group, but anything else other than an alkane, you have to explicitly say that it is present in the molecule. So here we have an alkene, we have two alkenes, here we have alkyne. So the next functional group you would want to know is an alcohol, which, as we have seen from the class, is something that has a carbon with an OH on it. So what else is on the other part of the carbon, that doesn't really matter, but as long as you have an OH, then you call that an alcohol. So this will be an alcohol, that will be an alcohol as well, and that's an alcohol, and so on and so forth. So as long as you have a carbon, oxygen, and a hydrogen bond, it's called an alcohol. And of course, as you have seen in the example I have given you, all these carbons are sp3 hybridized. So for now, I can guarantee you that as long as it's an alcohol, all these carbons are going to be sp3 hybridized. Alright, so keep that in mind. So sp3 hybridized carbon. The next functional group that is closely related to an alcohol is an ether. An ether is carbon, oxygen, except instead of a hydrogen you will have another carbon. So this is an ether. This is an ether. So an example would be carbon. In this case it's actually CH, right? And that's a carbon. This is an O. This is CH as well, I mean. So you have a carbon, oxygen, carbon. You can also have like that. So this is a carbon, that is a carbon, so this makes it an ether as well. So as long as you have a carbon, oxygen, carbon bond, that is an ether functional group. So the next functional group you would want to know is what is called as a ketone, which is also an oxygen containing functional group. So I am now focusing on functional group that contains an oxygen. So if you have a carbon, 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 you have a carbon on both sides, and the middle carbon contains a C double bond O. So it's not a single bond O, this is a double bond O. So when you have a C double bond O, when you have carbon on both sides of the C double bond O, that is what you call a ketone. What do you have else on that carbon, that doesn't matter, as long as you have this arrangement C double bond O C, that is what you call a ketone. And this should definitely be differentiated from an aldehyde, which is very similar to a ketone, except it contains at least one hydrogen. So it's very similar to a ketone as I just mentioned, but this C double bond O contains at least one hydrogen. So this is still an aldehyde even if you have a carbon on one side, but as long as you have the C double bond O with a hydrogen on the other side, that is an aldehyde. So this is also an aldehyde. This is also an aldehyde, but this is the only possible aldehyde where you have hydrogens on both sides, because this is the only structure possible. Whereas for an aldehyde like this, I can have a structure like that, which is an aldehyde, or I can have that, which is also an aldehyde, or I can have that. So all these are aldehydes. So these are all aldehydes. Whereas for as a ketone, both sides have to be carbon, remember. So this is a ketone because it's a carbon with a double bond O, and there's a carbon here, that's a carbon here, that's a ketone. And that's a carbon that is sandwiching the C double bond O. So these are all ketones. These are all ketones, whereas these are all aldehydes. These are all aldehydes. These are all ketones, and obviously these are ethers and alcohols. So these are examples of oxygen containing functional groups. So let's take an example for now to quickly look into this. Let's say you're given a structure like this, and I will have alright, and let's see if I can add some more. Alright, so if the question is identify all the functional groups you see in this molecule, Then this, let me use a different color. So this is going to be a ketone. This unit is going to be an ether. So this part, so the hydrogen here, if it's not given, you need to know, because remember, carbon is supposed to have 4 bonds, so you have only 3 bonds, so the fourth one is a hydrogen. So this is an aldehyde. I would include that as well, so it's an aldehyde. And these carbon-carbon double bonds, these are alkenes. This here is an alkyne, and this here is an alcohol. This here is an alcohol. So these are the typical kind of questions you'll get. You'll get a structure, you'll have functional groups in the structure, and you'll have to identify that. And obviously, as I mentioned, you don't have to say that you have an alkane, but these CHs, they're all alkanes, but you don't have to explicitly state that. So these are all the functional groups you have in this molecule.